a user group, so I stepped down and I back to running the user group. So with that said, can let me share my screen and we'll get this going. Okay, and hopefully, yes, please log me in. Okay, cool. And what we're going to do is we're going to do the following format, post the questions in here, and I'll briefly stop between sections, and I'll ask Mr. Paul if there is any questions, and then I'll address them then. That way we can keep it really going fast. I got a lot of stuff to cover. Okay, so again, a pleasure to meet everyone virtually. Okay, I'll stop my mic. Video in a minute once I get through the basic slides. But this is my LinkedIn profile. Just please reach out to me. Classically trained computer science in University of Rhode Island undergraduate, graduate, avid writer. I have almost 85 topics. I think I got 84. Some interesting things are in here. One of the things I recently talked about, and we'll briefly go about tonight, is what do you call it? Power Query. And we'll be talking about the Power Query activity in Azure Data Factory. And that's in the past called the Wrangling Data Flows, okay? I also have a bunch of topics on ADF2 Azure Data Factory here, so take a look at them. I don't get a chance to write as much as I would like because, this is my passion after hours. It's got a day job as a consultant, so it takes a lot of time too. If you're curious where I've been, take a look at this. I stopped updating it recently because I haven't been feeling too good, but I've been talking to a lot of fantastic places. Last week it was Pakistan, the week before it was Ireland, and then my own user group. So having a lot of fun talking about a very diverse bunch of topics. Okay. And when I put in the actual slide, when you talk about, what do you want to learn, right? What I see there as a consultant that's very hot and where a lot of new developments happening is Spark, regardless of whether or not you're running on Synapse or you're running it on Databricks. Databricks is nice because it's cross-platform, but Synapse is really great if you want to do something like serverless pools. And I've seen people who do Databricks will throw a serverless pool over it because maybe their end users are fanatical about, using SSMS. Okay, it's a great way to do it. The other way is MPPs, right? And Azure Data Warehouse, which is now Synapse, is there, and Snowflake is the other competitor in the market. Okay, and that's cross-platform too. So enough about where technology is going. Tonight we're going to be talking about Azure Data Factory design patterns. If you want to get this whole slide deck and everything, you can just go to my GitHub repo and go right down to Azure Data Factory and it has everything in here. Okay, so I'm going to stop that and we're going to briefly talk about this and then we're going to jump into the slides. So this is what's typically called a modern data platform, okay? And a modern data platform has a bunch of components. First thing is some type of storage. And Mr. Paul, if you hear anyone come on and could you just make sure they're muted so we don't get any background? And so we can see here that this is a storage account. Inside a storage account, you can have a storage container, right? And it's just like you can have multiple containers in there and inside the container. And again, you can see I'm using a naming convention here, SA for storage account. I just, for the heck of it, this is a play convention, but you can come up with a lot more educated ones, right? For means what is it for? ADLS Gen 2, right? In 2030, meaning, hey, hopefully I'm still talking in 2030, right? Same thing with the SC, storage container, same naming convention. And then typically we'll talk about different zones like bronze, silver, and gold. I'm going to leave this up here. We'll come back to it. If I go back to the portal, and if you don't know anything about Azure, um, just a quick introduction. This is a dashboard. You can pin different things here. I got a couple data factories here pinned. Key Vault's a great place to put actual secrets. You typically, when you do data factory design patterns, you might want to do a metadata driven one. And if so, you're going to be putting it into a table. So that's why this is here. And last but not least, if you're going back to on-premise, you're going to use a self-hosted integration runtime. So I'm going to stop my view. Can't see me anymore, but we're going to keep on going with the presentation. This is my VM, so we're going to minimize that and we're going to go to the slides. So I did this in Italy back in February, and thank you again, Mr. Paul, for having me at the Toronto user group tonight. Really excited about talking with you guys, and hopefully one of these days we can have these in person. So if you're having something in September and I'm available, I'll try to make it. So, we're going to be talking about exploring design patterns for data integration pipelines. And why do I call it data integration pipelines, not Azure Data Factory pipelines? Well, data integration pipelines are not only in old product ADF, but it's also in Synapse nowadays. They're not exact though. Some things are in Synapse, some things are not in ADF, and vice versa. Terminology. Terminology is one of those things that changes over time, but the concept of extracting data, translating in data, and loading data has been around. And the actual order of those operations could be changed, right? So sometimes you might want to extract and load and then allow someone where else do the T, which is transform. We'll talk about that pattern as well as an ETL pattern. When you're a system designer like I am, and that's why I get paid, I come in, I'm a data architect. I draw a diagram, I talk about the pros and cons of different technologies, and then once a client picks one, we actually go to, the actual implementation phase. And implementation, we actually have to implement. And one of the things I try to create is something called a loosely coupled design. Okay. And so I probably have this not on the hide presentation view. So let me do that. And in a loosely coupled design, okay, uh, it's great because you can make a change upstream or downstream and it doesn't actually affect anything. So if we had a tightly coupled design, any change in the source producers or destinations impacts the whole system. We have to redesign it. With a loosely coupled design, say if we are using a standard format to hold a customer, and the customer initially was coming from Microsoft Dynamics, and for some reason we decided to go SAP, right? As long as we kept the customer table the same, our downstream reporting wouldn't be affected by it, okay? So that's why you want to have these loosely coupled design patterns. So let me minimize this. What is a spoken hub, right? Lots, and this is a common pattern. If you talk to anyone about network security in the cloud, they might say, hey, yeah, we want a hub and spoke design. And also, guess what? A data lake or operational data source is a hub and spoke design. So we have basically producers creating some data. And the data can either be pulled or pushed into the hub, which is a data lake or operational data store. And then we go ahead and clean it up so it can be a single source of truth. And then we have consumers that are going to pull it out, say reporting AI. Okay. Typically today, like I said, a lot of people are going to data warehouses in the cloud, such as Synapse and Snowflake, or they're going to products such as Spark that work really well with data lake storage. Okay. And they use a Delta format. So let's talk about various file types and what's the benefits of each or lack of benefits of each. Okay. So, if I was in person with you, I'd say, hey, how many people have a CSV file? And you raise your hand and you go like, oh my God, you had any problems with it? And more than likely someone will say, oh yeah, I spent a night debugging something, right? Because someone put a carriage return in, or even if it's not a CSV file, but it's a pipe delimited file, and you thought no one would ever use a pipe, and guess what? Suddenly it breaks, right? So there's a lot of problems with these type of weak files, okay? Formats. A better way to store data is to use a strong file format. And Apache came out with three of them. We're going to talk about Apache Parquet tonight, okay? There's two other ones, Apache Avro and Apache Orc, okay? Why is this a better format? First, it's stored as binary, okay? So we already know what the column name is. We don't have to read the first row. And with the CSV, we don't know what the data type is until we start scanning the whole thing, right? So obviously, if we use in Parquet, we already know what the data type is. As for compression, well, you can compress a CSV file using something like gzip, but then we have another step to use. Apache Parquet, by default, it's a column store, and then we can compress on top of it. And last but not least, it can be split into multiple files, and that's really good when you use in Spark or anything that is parallel processed. So, why did we want to go with Parquet? Well, and what's happening is that in the future, okay, and again, we're not going to have the ability tonight to talk about everything you can do in the cloud. You probably want to go and use something called the Delta Lake, okay, and the Delta Lake is a bunch of Delta files. Now, why is a Delta file really important? Because it's a bunch of Parquet files put together with a log file, and it gives you something called assets, those same properties that we like about a database. it's atomic, meaning that one transaction, either completes or doesn't. It's consistent. So if we run the same transactions or the same order, we get the same results. Independent, two transactions don't depend on each other, and durable. Say the system goes down, there's some way to either play forward or roll back the transactions. Some other things you can do is either do schema enforcement or allow schema drift, and that's the format of the file. It also, because we have log files, unless you vacuum, you have time travel. You can go back in time and say, hey, this happened in the future or past, right? And we can do snapshot isolation, right? And that means that, say if we were writing this program in the past and it was just Spark, okay, and it wasn't a Delta file, I'd have to read up a Parquet file, make a change, and write it back. What happened if both of us read it up and we both wrote back at different times? The consistency of the data depended upon who wrote first, right? So if I said it's a 3 and you said it's a 4, and you wrote last, it's a 4. And if I wrote last, it's a 3, right? They're not isolated though, because we can have contention on writing, right? And this allows for snapshot isolation. Last but not least, it's an open source format. So even Microsoft has adopted it, and it's in the Synapse product. So a Delta Lake or data lake, okay, depending, the only difference between a data lake and a Delta Lake is if you're using Delta files, right? Has a bunch of zones, okay? And this picture is right from Databricks, okay? And it has two concepts here that are really important. First is it has something called Lambda architecture, okay? Lambda architecture is the way to process data two different ways. One is called the fast lane. The fast lane is we're getting data as fast as we can through streaming. Now, what is streaming? Streaming is like IoT events. Say I got a sensor in my GE fridge, and the sensor goes off and says, hey, open up the door. And then I close the door, and we can see how many times the refrigerator gets used. And if you have kids, maybe it's a lot of times, right? So, say it was hooked up to the internet and we sent it to an event hub. That would be your streaming data, it would be IoT data. And maybe that's one type of data you're getting. And what you do is you can, depending on service, you can read from a Kafka compliant service and write to a Delta Lake. Also, batch, and that's what we're going to talk about tonight, is something which we periodically go out and say, hey, is there any changes? And that would be like an incremental load. Or guess what? It's small enough. I just want to know all the Powerball numbers. So did I win today? Right. So I could just pull out, or did I win in the past? Right. Now that gets us into the first zone, which is called bronze. And at the bottom, you can see this is data quality. And a lot of times people call these raw, refined, and curated. Or, if you're using types of metal, bronze, silver, and gold. What's the difference between all three, right? RAW is when you bring the file in. So say we're getting data from AdventureWorks, and that's what I'm going to use tonight as an example. The data is coming, say, from a SQL database on premise. And a lot of people have stuff on the premise and they want to bring it to the cloud to have like the single glass, pane of glass reporting so they can see it from maybe the AdventureWorks as their ERP system. Let's just make this up, right? And then you have some IoT data that shows, hey, maybe someone bought a bike and how are they using it, right? And then maybe they have some internet sales data, right? So we're bringing all this into the bronze, and it might be in its raw format, say a CSV file. It's not the most optimal, but if that's the only file format we have, we go with it, right? Then the second one is the silver zone. We might actually put that into a Parquet file. Now, remember I said it's ACID transactions. It supports upsearch, right? So you can do an update, an insert, we can do mock delete, so we can keep now track of a history in silver. And last but not least, in gold, we might want to just show the most recent data and somehow enrich it, maybe multiply a couple tables. So take, for instance, say we want to know where those bikes are going and the customers. So we want a shipping detail. So that might include the sales header, the sales detail, right? The customer and the customer shipping address, right? So now we're pulling in like four different types of tables from silver, coming up with a gold zone, okay, which would be one flat dump that would be our shipping report, and that could be our report. We could also do AI, okay? So this is the data lake and zones and quality, okay? It's very standard. How you use these, though, is all dependent upon your business. So load patterns. We're going to talk about two load patterns and one that you can modify the last one with. Okay, so the first load patterns really used for small to medium size. Medium is, uh, deterministic on you. Okay, it's from person to person. Okay, and this pattern, the full load, pretty much say if we were doing a delta table, we would just drop the directory. Delta table is just Parquet file and some log files, right? Get rid of it and then reload. We got a brand new directory. It has the most up-to-date data. Okay, so very simple load pattern. Problem with that is what happened if that's 4 terabyte of data? Well, wow, we have to upload 4 terabyte data to the cloud. And if you have Express Route and say you have 1 gigabyte per minute, and I'm just making this up, maybe it takes 2 hours, right? You don't want to do that every day. That's a lot of transformation time you have to spend bringing the data up to the cloud. Is there a better way to do this? Well, the better way is to do an incremental load, okay? And so what we want to do is merge the target data set with a small data set that represents a change over a given time period, okay? So for instance, a daily update file. And this pattern can be used to, up to small, medium, large file sizes, okay? The interesting thing with this pattern is you still have to seed the data, just like, you know, uh, availability groups. You have to start the replica with a copy of it. Same thing with incremental load. So that means that hopefully you set up some watermarks and you can say, okay, I want 2 years worth of data. Let me start back 2 years ago and say we start back in 2019 January and we say start from the 1st of January to the 31st. Give me a file. That's my first file into the Delta. Now, and guess what? Get February, repeat it again 24 times and merge them in. And suddenly we have this big file in the cloud. Okay. Last but not least, these large data sets, how do we find data? Right. And when we do data searching in a database, okay, you do it by having an index. An index helps you. There's something similar called a partition, right? If we partition the files correctly, and we know we're doing a lookup pattern always by, say, year and month, we can partition by that. And now when we do a query, we can say, oh, yeah, we want to look for January's data. It knows which file it is, okay? In reality, it'll partition by file and by folder, okay? And there's something also called Z order in Databricks that you can actually even fine tune this, okay? So at this point, I'm going to pause. Was there any questions?
Don't see any question, but please feel free to ask if you have any question. You can just unmute yourself and ask the question.
Sure. I'll keep on continuing. And if you do have a question, just, put it out in the chat and I'll be notified. And if not, I will just, you can speak up too. So, historical background, the ADF came out and was designed as an orchestration engine. The first release is in 2015. It's like any product that any company comes out with. I've been doing this for, oh God, 32 years almost, maybe even more if you count, my undergraduate when I worked for the Navy. And so I remember when Visual Basic 1 came out, okay, and no one used it. And Visual Basic 2, people started using, but it wasn't widely accepted. And when Visual Basic 3 came out, everyone started developing applications with it, right? It's the same thing with ADF, right? Azure Data Factory came out in the summer of 2015. It wasn't the best product, it worked, but you know what happened is the second release, which was in 2018, okay, 3 years later, they fixed all the problems with it and excels at connecting. Okay, it has a ton of connectors, so you can connect to many different sources. Okay, it's really good at orchestration, so it can, remember we talked about ELT, so we extract, we load, and then we translate. It does that really good, and what it is it does delegation, meaning that it delegates out to another service to do transforms, and it allows you to do a combination of legacy and modern environments. It's called a hybrid approach, and we'll get into that tonight. In the fall of 2019, a year later, they came out with something called mapping data flows. And this is kind of right after they went in partnership with Databricks. Microsoft owns a part of Databricks. And Databricks putting their application on, Azure, the engineers learned some things and they're like, oh, wow, we want to come up with something that looks like SSIS in the cloud, right? You can start with a source, you can put some transforms in and end up with a destination, right? And this The very first version was ELT, extract, load, and translate. This one allows you to do ETL. And again, the slide's a little off. I'll have to fix it one of these days. Every time I see it, I go, yeah, I'm going to fix it. And I never get to it. And we'll talk about that.
30 lose John voice. John, are you there?
Yeah, yeah, I'm still here. Can you hear me?
Yeah.
Okay. So where did you lose me at? Did I talk about mapping data flows?
Yep. We hear that.
Okay, good. So mapping data flows again is an ETL product. Under the hood, it's run by Spark. It kind of resembles SSIS. You have mappings you have to do. And wrangling data flow is more like Power BI, in which you have columns and you bring a thing in, and what you do is you right click. Like, I want to remove this column, right click it. I want to split this column, you tell it to split, and so on. And there is some restrictions right now, and hopefully Mox Group is fixing those. I wrote an article in 2022 of February, just recently published a few months ago, and it goes over some of the issues with the current version, but hopefully they're getting fixed, and I think it's a great product. So what is the center of this? It's the copy activity. It's the center of this whole design pattern. Data is moved from a variety source to destination. External computing is used in the translation. Both SQL Server and Databricks are popular computing endpoints, okay, to do that transformation, okay? And how does this paradigm work, okay? So regardless of whatever you're doing, okay, it's built on like almost like a Russian doll in which you have one doll at the basis and then you keep on adding. Okay. So the base doll is a link service and that's your connection. Where does it connect to? Is it a Hadoop cluster, SQL Server, Databricks? On top of that, the next thing is once I know I'm connecting to, and I know that it's a SQL Server database, right? What's the data set? And the data set is like the schema and file. Once I get the data set, okay, and I say have two link services. So I'm going from Azure SQL Data-based table to say Azure Data Lake Storage Parquet file. Okay, and I got those both defined, okay, as a link service and a data set. The activity is the copy activity, okay? And that's all packaged together in something called a pipeline, which could have parameters. You can schedule it and you can manage it, okay? Triggers are something that you put on the schedule. They allow the pipeline to execute. And alerts can be added so that if a package fails, you get a notification. So one of the things I talked about is the hybrid fact that ADF can be hybrid. And how does it work? Okay. Well, under the hood, and I've done a little research on this, and I've been using this product for a good 3+ years, that I know that Azure Data Factory, when it sets a trigger off, it's actually taking this code and put it on a service bus saying, hey, I got something to run. And what happens is if it's an Azure integration runtime, or it's a self-hosted integration runtime that we installed on a VM that's on premise, it looks for that package. Okay. So say we were trying to copy from on-premise to the cloud. How does the self-hosted integration runtime works? Well, first is either this line where my cursor is going all the way down and to here is express route. If it's express route, then the packets are going through a back channel and you don't have to worry about them going over the public internet. If it is not express route, it's using HTTPS. You can also have VPN, but I assume they're in the same bucket. It's a secure channel. If it's not a secure channel, it's going to a public internet, but it's using HTTPS. So once it pulls down that message, hey, what's the source and where do I need to go to? It actually on premises checks the credentials. Hey, I'm logging to an on-premise Microsoft SQL database, getting AdventureWorks and then copying it to ADLS Gen 2, and it's going to execute that. So it needs a connection for both, and then it starts migrating data. So here's some of the objects that are you can draw on a package, and we'll get into 'em in the next slide. But they allow you to do extract, load, and translate. So data copy, that's the most important. Data flow, that's the mapping data flow. So we'll talk about that. Azure Data Explorer, haven't used too much. Azure Functions, a great way to call a Azure function, and the Azure function could be backed with a Office 365 connector to send mail out of the box. One of the deficiencies I see with ADF is that it doesn't have a component to send a message on an error, but you can make your own using Azure Azure function. Okay, batch service. If you need to scale something, it's a great way to do it, or say run some PowerShell. Databricks. I use this a lot in my designs because a lot of times we use the extracting load for ADF pipelines and we execute a notebook to work in a data lake. Use SQL is deprecated. It's an old way to work with data lakes and it's only supported by Gen 1. All these right here are different ways you can do stuff. Like we can create a variable, set it, we can append to a variable, we can delete a file or some object, we can execute a pipeline, so we can nest pipelines now. You can also do SSIS packages, kind of old technology, so I won't get into it. Get metadata. Hey, I want to get list of files. Lookup. If we're doing a metadata-driven approach, we want to get a list of, say, tables. You want to copy it over. So the lookup would return an array. And then we could say on this one, iterated controls for each element in an array, do something, right? And then it's be execute a pipeline. And that pipeline could take the parameters to copy from, say, Azure database SQL database table to a Azure Data Lake storage Parquet file. And if we write that with parameters correctly, that for loop, guess what? We can do it iteratively and we write two programs and we're done. One would be the parent, which would do all the metadata lookup, and the child would do the execution. Stored procedures. That would be like running a stored procedure on Snowflake or in SQL database. They just actually came out, I don't know if it was last month and a month before, with the script activity. So in the past, with start procedures, you had to call a physical start procedure. You couldn't do a DDL. So DDL is data definition language, like create database, create table, create view. But now you can. Okay. What else we have? Webhooks. The web is pretty good right here if you want to do web scraping. I've done that in the past. Hey, I want to have a page that has static data. I want to pull it. Perfect. Waiting's good sometimes when um, with Databricks notebooks, it takes time for the cluster to come up. So you can put a wait in there to make sure the cluster's up before executing. I'm going to skip over HD Insight because it's older technology. Most people are not doing it. Machine learning, I'm going to leave off too because that's an advanced topic. But if you had stuff in here, you could call it. And you have your typical things like if condition can be replaced with a big switch. Okay, we got the for loop. We can actually filter some data and we have an until. Okay. So let's do some demos. We're going to talk about hard coding versus notebook parameters and why notebook parameters is better than hard coding. We're going to talk about how you can take a pipeline and support multiple file formats. Then we're going to talk about supporting on-premise dataset with self-hosted integration runtime. And we're going to make this really cool by taking that parameters and creating it into a single, okay, parameter, which is really basically a JSON document. And the JSON document allows you one-to-end parameters. So it's a lot better than passing parameters because, I got this notebook and suddenly I need to add a parameter. Oh my God, I have to go change it. But if I'm just passing a JSON document, who cares if it changed? We just have to look for the new one on the actual child that needs that property.
John, you'd like to take one question?
Sure. Thank you for asking.
Sure. The way I ask, I'm just, reading.
Yep.
For the offset to Parquet on data lake, do you apply some kind of pattern for the update? As I remember, Parquet is not designed for updating the original file unless we just overwrite the same file. So he may be asking like if Parquet can append the data.
By itself, it can't, but a Delta Lake format does allow appending, and that's why when you want to do that, you want to use a Delta Lake format.
Okay. So still that is Parquet, right?
Uh, it is multiple sets of Parquet.
Okay.
So you'll have your let's talk about we load up the United States, right? It was 50 states. And say I decided that I wanted Rhode Island to have a new abbreviation. I live in Rhode Island. So I'm going to call it instead of RI, I'm going to call RH for some reason. Okay. I go and I try to do an update. And what it's going to do is going to create a new Parquet file with that new entry. But there's also going to be a log file there that's going to tell it, hey, by the way, the old entry is not really valid and the new entry is a replacement, right? So that's why you have log files as well as Parquet files. And when you take them all as one in the Delta format, you get a consistent look. And that's why you can go back and do time travel. If you go back in history, you can see, hey, it was RI, but today it's really RH because we made that change.
Got it. Thank you, John. There is one more question
Sure.
from Ahadjan. John, would you mind to unmute yourself and ask the question?
Yes, hi, thank you. So, for this self-hosted integration runtime, should you have so on-premise for your on-premise computer must have a public static IP address, or can it be a non-static?
Good question. It doesn't need to be a static IP address. Again, what's happening is that self-hosted integration runtime is looking for the service bus and says,
Mhm.
hey, I got something that I need to run. So it pulls that information down. And in there, you're going to have the credentials to connect to your on-premise data source. So in this example, I'm kind of doing with my hands. On-premise, it's Microsoft SQL running AdventureWorks, and I want to put it in the cloud in ADLS Gen 2 and some type of folder and some type of file, which Parquet. To do that, what it does is it starts the transfer and it reads bytes by bytes, packages up in a Parquet, and sends it through HTTPS, okay, to the ADLS Gen 2 server and then lands the file. So that's how it actually works. So IP has nothing to do with it. As long as there's a route from that self-hosted integration runtime to the cloud to pick up those packets of work, it knows how to do everything else.
Thank you.
You're welcome. And the only time it's really important is that when you have something called private peering. That's express route. And when you have private peering, um, the actual private peering, sorry, I just saw something blip. There has to be some connection between on-premise to the cloud. So if you suddenly put in an IP that's not part of that VNet that's peered to the cloud, you're not going to have access. Okay. So if you are going express route, make sure that VM that has the self-hosted integration runtime is part of private peering.
Thank you.
You're welcome.
John, there is a follow-up question from Ray.
Sure.
Again, we did Parquet. I think it's very interesting question. Is my interest too. What Ray mentioned that what about when you updating an entry inside a table on Delta Lake, mini Parquet file, does Delta Lake just read in all the files for the table and make it a historical snapshot? Then you simply write the same set of files over to the current version?
Okay. I think the answer is no. I think what it's doing is it's updating those changes into the Parquet and the log. It's keeping track of when those changes happen. So when you go back in time to like each time you commit a transaction, that is a point in time. So if I did an insert, I would have three, and they were separate transactions to the Parquet Delta Lake file, Delta table file, really it's called, right? Then you would have those as points that you can go back in time to. Those are very specific. Please take a look at the documentation from Databricks. It talks all about Delta Lake, and it's probably a lot more understanding than I'll ever need to know. Only thing I know is it works, and I just write to it.
Well, John, now I have a question. It's still, this is related to the Delta Lake. So,
Sure.
um, if there is, let's say, for example, 15 or 10 files, say, okay, 10 files, and you
Yep.
mention, okay, this is a Delta table. Say, I would like to browse, say, I'm data scientist. Would like to browse the data. Is that I can browse the data and as a one whole table, but it's still like tens files data will be appended, kind of not really appended underneath, but when I look or browse through the data, say for example, one file have 10 records. So will I see like 100 records for with the 10 files? Is that how the
Okay, so here's
explosion?
the problem is that
Right.
you have to be careful, right? In that directory, you're going to have a bunch of Parquet files. If you decide to go ahead and Spark, say I'm using Spark and read up all the Parquet files, it's going to give you everything, right? And then you're going to get inconsistent, right? That's why you have to use the Delta Lake I meant the Delta table connector, okay? So when you tell it read a Delta file in, okay, it's smart enough to know that, hey, there's log files there as well as Parquet files, and it puts it together and puts it in memory the right way it is. Now, when you look at, you get the current version, okay? If you want to do time travel, then you have to tell it, hey, load it up and then post date it to this timestamp so I can see what it is, okay? So a little out of scope on this because we got a ton of stuff to talk about how to do metadata driven approach, but those are all good questions. And if you want me to come back and talk about, Delta file format, I can.
Thank you, John.
You're
It was
welcome. So I'm going to stop the camera and I hopefully still sharing. Okay, so now what we want to do is we want to get into the examples, right? So this is Azure Data Factory, and we have this one is the storage account. So we're going to click this one open, okay? And we're going to open up the studio. Okay, now in the studio, this is your main home page. The main thing is make sure you connect it to Git, okay? So you can click on this and you'll see that I'm connected to Git because it's a master branch. We can create a pull request, pull it down. We have the publish branch, and then we have live mode, okay? Okay, so the first one I'm gonna do is the hard code pipelines, okay? You can see right here, I'm actually using a naming convention. Where's that naming convention coming from? Well, good question. I did not come up with it. There's a guy named N. Davin, and ADF naming, and you go here, and basically I'm using his. They're really cool. And again, sometimes change them, but MSQL is Microsoft SQL. LS_SQL would be a link service, and SQL would be the data set, right? And then we can go all the way down, and we start to get into stuff like, hey, DPL for pipeline data versus transformations. And then we can come down ACT for activity, MT for move and transform, and then CPY, I don't like COPY, for copy versus data flow would be DF. So you can see how this naming convention is going. Excuse me. And this is what I'm using, okay, in my, you know, copy table. You can also see that we can have, did I move this by mistake? I might have moved this. Yeah, that's why I probably did. We can also say, let me get out of here and go back. I must have moved it. Leave. Go back. Nope. Okay, well, let's go this way. Just be careful if you're in here and you make a change, just get out of it if you don't want it. I was like, I don't think I want that. So go back in. Hopefully, maybe I moved it a long time ago. So we'll bring this one in. And now if you make it, you save all, right? And then you publish and it's suddenly there. Cool. Okay, let's see what this one does. Okay. Oh, so you know what this is? Annie Leonard was down at my user group and he wanted me to demo something, and that's why that's here. So I'll leave it out. It has nothing to do with the demo. I just need to push it in its own directory. So we'll get rid of this. That's why that's there. So the very first one is copy SQL table, which I've been talking about, EventWorks to a CSV file. So we're going to click this one. This is a copy command. What's inside the copy command? We need a source, right? We can see this is EventWorks source. Well, where does this source come from? Well, I know that down on manage, we have something called link services. And on the link services, we can carry various things. Like remember I told you there's a web connector? This is Wikipedia, and it's talking about Super Bowl. This is a file share for NTFS, okay? This is on-premise SQL Server on a VM, right? This is some tips on Azure SQL Database. This is AdventureWorks. This is the one we're using, okay? And we can see that in here, we can connect to it many different ways. One is we can connect to it using a fully qualified domain. We can enter it manually, or we can do it for some subscription. We can also give it the database name, or we can create a parameter if we want. And if we use system side manage identity, it's the best way to do it because you don't worry about connection strengths. You worry about the system to figure it out. Okay. You can also create up an old fashioned user account, put it into a key vault, and pull it. So that's the old fashioned way to do it. If we always want to test something when we create it, because if it doesn't test successfully, then there's some connection problem with it. Okay. And like I said, we could add parameters here. We could parameterize, say, the database name if we wanted to. So now we have a connection, okay? We can see there's two things here. So we have a data set and a copy table that's associated with it. So let's go to data set. And we can see that this data set that's being pulled is the sales LT, okay? And there's no parameter, it's hard coded. So if we hit preview data, we can see that it actually works. It goes out to my Azure SQL database in the cloud and pulls down the address table. So if we go back to the full pipeline, we can now see that we have the source, which is the data lake. Now, excuse me, let me give you some pro tips. One of the pro tips is by default, the timeout is 7 days. Please change it. I usually make it something reasonable. This is 5 minutes. Hey, if it doesn't happen in 5 minutes, then guess what? I don't want to error it out. Also, you can say something's really critical after 5 minutes. Maybe I want to try it one more time. So I could say one try and I'll wait 30 seconds and then try another 5 and then fail it. So we talked about same thing with the query. How long does this query take? 5 minutes. So at most now we're going to fail in 5 minutes. We can also do petitioning if you want to make something fast. And we'll talk about where this might happen at the very last data flow we're going to talk about, pipeline. And then we can see that the storage in here, we're going to pass some parameters. Okay. So if we looked at the data lake storage for CSV, which is, where is it? This one. Pretty sure, right? No, it's Excel. Always get it wrong. Where is it? Might be this one. Yeah. So in this one, we can see that it's actually asking for a directory name and a file name. Okay. It's going to do a comma delimited as a default. Okay. So now I'm going to minimize this. We go back to this one. Okay. And we can see now that we have the data lake storage. We could open as another way to do it. We're passing the path to bronze design 1 sales LT address. How do we test it? Well, we want to go bronze, design 1, sales LT, address, okay? Well, the easy way to do it is get rid of the file and see if it regenerates it, right? And if it regenerates it, then our ETL works, right? And we could download it and take a look. So I'm gonna click this one, say hit delete, get rid of it. Okay. It's gone now. So we have no data in the destination. We're gonna extract and load to the data lake a single file, no transformation, okay? How do we do that? So we hit debug, okay? And debug is going to actually kick it off. It's going to go to the self-hosted runtime, which we can see here, integration runtime, not self-hosted, but the auto default, which is in Azure. Now, how do you specify the runtime? It's when you create the link service, you can tell it which runtime to use. If you don't tell it anything, it uses default. We see it success, okay? Now let's look something at the details here. Everything in ADF, most everything, is JSON. So we can see that this was passed. We said the query timeout for the whole thing is 5 minutes. We told it it's text. Okay, that's what came in as input. We can see what the output is. It told me how many bytes it read, how many bytes it wrote, how many files it worked, how many rows it went, the throughput, okay, so on. The engine that ran, auto-resolved integration runtime in Azure, so it's not a self-hosted, so it worked. And if you wanted proof, you just hit refresh and guess what? Now we have a file there. And if we want to download it, download, we can take a download of it, show in a folder, and then we can right click it, bring it into our Notepad++, that's my favorite notepad, and we can see that we have the data here. Okay, so does anyone see what the problem with this design pattern is? Any takers? The problem with this design pattern, it's all hard coded, right? It's really good, okay, for just one thing. It can copy one file over, okay, and it's only one file format, and the source and destination are kind of fixed, okay? So let's fix that. So what we're going to do is we're going to do a parameter-driven type, okay? So we can go now and do the CSV. One of the things you can do is you can look, okay, at um, the actual pane here is the pipeline, and pipeline you can do a couple things. Parameters is what you pass into it. Variables are things that you want to calculate with inside as helper before you pass them to the next, say you had a bunch of activities, you could, before this, say set variable, and you could set the variable some calculation you want to do and use it in the copy data, okay? So this time now we're passing the schema name, sales LT. We're passing the table name, address, so that's our source. So now it's dynamic. I can make it anything, okay? The zone, where I want to put it, bronze, design 2. The file type, well, I'm going to tell it to CSV, okay? So now if we click here, we look at the source, hey, it's a little more complicated. Instead of just being a table and using a connector, which is hard code, no, what we're doing is we're doing a query. And how does it come up with the query? It's using a concatenate, say, and select star from the schema name dot the table name. Well, those are parameters, so we're going to pull it in. If we were doing incrementals, we'd want to pull in a watermark at the same time, okay? So we're pulling in a full pipeline, all the files for a given table. Sync, what are we doing? Same thing, we're actually concatenating the zone with the schema name as a directory and the table name, okay, as another directory. And then underneath that, we're going to take the table name, okay? We're going to do a hyphen. We're going to create a date time string, okay, using UTC, and we're going to put the file type at the end, which is CSV, okay? So it's a little more complicated. Let's run it. So now we can do this over and over and do a bunch of files. Now, one of the things I want to show you is this, is that if you click the code button, which was the 2 curly brackets for JSON, everything you do in ADF is basically JSON. So this one right here, the pipeline's JSON. So if you ever needed to copy and paste this to another, environment, you could. It's not the best way to do it. I suggest using uh, Azure DevOps and, continuous integration, continuous deployment, right? Deployment pipelines. And what we would do is, but we could manually copy it over if we need to, assuming that, some of the things were there. If the link server was there and if the data set was ready to find, then we could just copy this over by creating a new one called PL copy SQL Table to CSV file v2. And if it wasn't ready there, we could just paste over it and we could put an update. So this ran, we can see that same thing, 450 rows. That's great. Same answer. Let's see where it is. Well, this one wrote to, I think it's bronze too. So let's take a look. Is there any questions in the window?
No.
Okay, maybe it's just my window. Sorry about that. I got a couple ones going.
I
So,
had one quick question.
sure.
How can you view the parameter settings in your run below? Um,
Yep, good question. Uh, again, we're not going to see them here. Okay,
okay,
we can, because what happened is it actually, when we run it, it actually put everything together. So you only see what's being run. So we can see that it ready did the select star from sales LT. That's our source. And the sync, it's telling you that file extension's here. And sometimes it doesn't tell you all the information here. The output, let's see if the output gave us it. It told us the number of units. It told us that we're going from Azure SQL Database to Blob Storage FS for file system, which is basically ADLS Gen 2. And I don't see it here. If we ran it through a debug, it probably has it. And I'll show you the next example. It's a good question, how we're going to actually parameterize this to do it multiple times, okay? And so I didn't exactly answer it, but again, when it's running, you can definitely see it. So what we did so far is just copy one file over, right? And that's nothing to write home about. Say I had 100 files I want to copy over. How do I get 100 files over there? So I talked to a client today about this. So we're going to see multiple files here, but we can see that today, right, I ran this 3 times already, okay? And we can see they're all CSVs. Okay, so this is 2300. This is probably UTC time. That's why it's so farther ahead of us, 5-6 hours, right? And it's almost 1 minute past 28 seconds. Okay. So let's go up one and take a look. So I said I ran this before. Let's see the customer. Customer should only have 2 files, right? So it has the 26 only ran it once for them. So we're going to run it again. How do I take this parameter driven one and run it multiple times? Well, the thing now is we can create a single job. And in that single job, we can call each one. So I'm calling right here this, but then I have to type in this, okay? And this is kind of labor intensive. I have to put in sales LT address, bronze, and CSV. It's getting better though, right? I can now, before the other one could only do one thing. Now I can actually do 10 different ones. So we're going to try this a little different to address that guy's, the person who spoke up and said, how do I understand it, right? We're going to trigger it, okay? So I'm going to trigger it and hit OK. So this is going to trigger. What's trigger doing? Trigger is actually going to put it into the pipeline runs. So it's a different part. It's the monitoring part of the product, okay? And we're going to see what's going on. So it's going to run 2 pipelines at a time, okay? We used to have ability to refresh this. Where's the refresh? Maybe this one. They always keep on changing things on me. So it's executing right now. So we can now take a look and let's see if, there you go. Does that answer your question? See right there?
Yes.
Perfect. So when you're in a debug mode, doesn't help you. But when you're not in a debug mode, everything's crystal clear. So I knew it was somewhere. So you definitely tested me on that one. This one's taking longer to run though. Maybe it's trying to figure out where it is. You would hope that it's running. So now if I click over here, okay, so it succeeded. Okay, so this is the sub one. So if we come back, we can see this is running. And so this is the parent, so it's waiting. Whoops. So now maybe this is running because we have a bunch of them. Okay, there you go. So we've done 4 of them and there's 10. So I'm gonna let this go. In reality now, know what's gonna do. And again, I have way too much to talk about to just stay on this. But let's go back to here is that we're going to see if we hit refresh, there should be a new file here, which we have. So it did a customers file. We come here, guess what? This is 5 past the hour, right? It's now an address file and it's doing it alphabetically. So eventually, if we come down here, we don't have this yet. So, well, it looks like we did. So 23.6. So let me go back. Maybe I'm done. Refresh. Almost. And that's it. So it's waiting for copy product data. So that's it. So maybe a little out of order on the last one, but that's it. So is there a way to make this pattern even better? So far, we've gotten first it's hard coded. Now it's parameterized. Can we do multiple data formats? Let's try doing that, right? How do we handle that? Well, no, what we need to do is we need to create a data set, okay, for each one. So what we're going to do now is we're going to go ahead and we're going to use the if statement, okay? And it's finally finished. So on the if statement, what we're going to do is we're going to take that single copy and instead of just passing it a schema name, a table name, a zone name, and a file type, we're going to pass it extension and a delimited character. So extension and delimited character will be only used by delimited types, but the file type will be used by many different ones. So if we have if delimited file, okay, we're going to go in here and we can see now the source is select star always, but the sync's going to be different. This one's going to be our delimited source. And again, we're going to pass a directory name, the file name, and the delimited character, okay? If we didn't want to do that, then the next one we're talking about Parquet, right? So that's a very good format. We got to walk in here, we got Parquet. So now we can see here, if we go here, how does this determine this? Well, we're doing a little function. If the upper of the parameter is equal to Parquet, so because I'm testing for upper, say if someone spells it wrong, then case wrong, then run this job. And if we go into Parquet and hit this, we can see that now we have the source the same, but the sync is now a Parquet format. Nothing to write home about. So let's run this again to test and hit debug. So we're going to do sales LT, address, bronze, delimited, CSV. Okay, it's a comma. So we hit run and let's see what happens. So we can see each time we're doing this, we're getting a little better at it. We're refining it. So what's happening now is that I'm actually executing each of the if conditions. Okay. Now, one of the things you can talk about Mark, and maybe he can give you the answer behind this, because I asked him this question and he never gave me the answer. Mr. Paul, next time you meet him next month, is ask him why you can only put 40 different objects on, the pain. Once you have 40 different activities, even if they're nested or not nested, you can't draw anymore. It's a limitation. And what's actually, this is being run underneath. It's actually running under Azure Functions, okay? So an app service, so Fabric. So if we take a look at this, it detected first each one of these. It had to run 12 seconds for these. Okay, then it finally found that the 2 seconds for each of these, and then it found the delimited format was the one we wanted to do, and that ran that for 12 seconds, right? And we can take a look at the if condition, and it doesn't give us any more detail other than it ran, right? Um, and so at this point, it's done. So if we go ahead and look again under the directory, and again, is this design 3 or design 2? Must be design 3. Open. Yes, it is. Design 3. Nope, it must be the main design then. Sorry. Right here. There you go. And if we looked at it, right now it's 709 on 26, and that's where it ran CSV file. Okay. So we're keep on refining our process over and over. Can we get the last process in which we have an awesome design? And we can definitely do that. Okay. So what we're going to do this time, a little different, is we're going to use a switch command. Switch command allows us, it'll find the right one. It doesn't run all 6 commands. It'll just find the right one right off the bat. So if we click on it, right, we're going to basically say, hey, take the metadata now we're passing. Oh, that's different. We got metadata. Why is that different? And then we got file type. And it says JSON. What are we doing here? Something's different, right? Well, guess what? Instead of passing all these parameters and these parameters are fixed, right? What happened if I want a dynamic set? Like I'm pulling from a table and I make the table wider. Well, that's a metadata driven approach, right? So if we do Control C here, and if we do a file lookup, okay, that's what it returns, okay? So if we paste this in, now we can see a lot of the stuff that we had before is now part of a JSON document. We're just going to pause it. So we have the database name here. So this is where we're connecting to. We have the table we're working with. We have schema table, right? We have the zone. We're going to go to zone 3, design 3. It's the third design. We're going to do a parquet. The file extension for parquet is parquet. And the reason why we have these duplicates, if it's delimited, maybe we want CSV. If it's a comma, it might be PSV if it's a tab character, or maybe it's PSV if it's pipe delimited, okay? So here's our JSON document that we're going to pass as a parameter, which could be a lookup. A parent could be calling this from a child, right? This would be the child. So we're passing the load in here, and then what we're going to do is we're going to find the right one. So we're talking about parquet, so let's find it. So we go down to parquet. The only difference now is that the way we do parameters, we have to count for it to be a string and cast it to a JSON. So this is a string coming in, pipeline parameters.metadata, but the metadata is a big document. So we want to first cast it to a string, right? And then we want to, after we cast it to a string, we want to cast it to JSON and pull back the database name, okay? And we can repeat this over. That's just the database name that we're pulling from. And then we select star from, and we're pulling back metadata schema name / table name. And then target, we're just going to repeat it, right? So sync, we're going to pull in the directory name, the file name. Okay. So at this point, we're just doing parquet. It doesn't have any other parameters it needs. Now let's look at how we're actually going to call this repetitively, right? We have a schedule here. I also have purposely put in 2 extra tables here. We have the big data, big products, and big transaction history from Adam Mechanic. Okay, so this is going to give us a lot of records, and I just want to stress. Remember when I showed you can do copy, you can do partitioning. That might be a case in which we were running this real live. We'd want to do partitioning. Also, one things I did kind of gloss over when you come here. If we go to the delimited again and take a look, okay, this is actually this guy right here. Go here and take a look at the source. We changed it from the cloud to on-premise, okay? So I wanted to show you real quickly what on-premise looks like if we were doing a self-hosted integration runtime. So in here, there is going to be, okay, something called Microsoft's integration runtime, okay, and hit yes. Okay, we can see it's connected. Okay, it's telling me it's connected to Azure Data Factory tips. Okay, 2021. And this one's called Shire 01. Well, if we go into the cloud before we run this, we can go all the way down here, okay, to integration runtimes. And we can see this is published. And if we clicked on it, okay, you can tell that it's using 11% CPU. And given the number of cores, it can use so many units of work, 12, okay? And it's running, okay? And if we had high availability, we'd have two of these, okay? But it's no high availability, okay? So if we go back to this, okay, I'm going to kick this off and then we'll talk more about debug about this. So we have the self-hosted integration runtime inside here. If we look at SSMS real quickly, we're running SQL 19 and there's a version of 2012 database. So this is coming up. Don't recover. We're going to connect. And we go to databases, and we can see we have InventureWorks here, right? And we are going through the LT ones, right? So this guy right here, and we can see we have tables, and we have this big product and big transaction, okay? So the problem is with big transaction, this is 18 million rows. These are all a couple hundred rows, okay? Last but not least, to generate Parquet files, what do you need? Okay, most people are going to be like, oh yeah, I installed it, didn't work. Why did it not work? If you look at the finer print under um, the installation guide, okay, you can look under program and features, okay, and we can see what we had to install. So the very first thing is obviously integration runtime. You have to install it. Second thing, Apache Parquet file, right from the Apache. Java. You have to have Java, okay. And last but not least, it has to be like 8 and then 64-bit. And one more component, because it's Microsoft and we're working with Microsoft tools, we need to have the Microsoft Visual C++ 2010 x64 redistributable, okay? So we have all those, right? So it's gonna work, okay? We can hit the refresh button, and guess what? It just copied to Parquet, and I'm stupid. I ran the same flow again. I wanted to run this flow. I'm gonna run this and then go back to the slide deck. So I'm running out of time and we'll get there. So we talked about hard coding versus notebook parameters. We talked about multiple file formats and I showed you the best format is to pass a JSON document, which could be a single row from a table, right? Because that's how a lookup works. For you to complete this is you just write a parent-child relationship and you have a metadata-driven approach, okay? Let's talk about the pros and cons of ELT, okay? 90% of review. Okay, almost all components can be parameterized. That means the master pipelines are used to call a generic pipeline. So we can say, hey, this master pipeline will read up a schedule from my metadata, and it'll say, oh, I'm smart enough to know that I need a copy from Azure SQL to database, call this child pipeline, and this runs it, okay? Where does transformations happen? We didn't talk about anything in transformation. That could be a whole talk in itself. And what you do is you write a notebook, they take parameters, or you write a stored procedure, they both take parameters, okay? And that's how you do transformations. How do you go faster? We can execute multiple pipelines in parallel on a subset of data, okay? So first is that big data problem I talked about. Say if you want to go fast, it's going to take 3 minutes. I've already done this like a dozen times this talk. I want to get down in 30 seconds. Well, guess what? I might want to run, I don't know, 10 of them, try it. Or whatever, 6, try it, might be getting to 30 seconds. And now we would use some type of hash function to figure it out and maybe look at dates, okay? Uh, ways to optimizing it. For SQL, if it's a target, use the batch size. For Spark, it's the cluster, okay? So ETL. One of the things you can do with the ETL, which is the data flows, and I don't think I have enough time to really get into it other than talk high level about it, is that the source and destination has to be in cloud. That's where Spark works, okay? It doesn't have these fancy connectors that the self-hosted integration runtime has. Under the hood, mapping data flows are using the Spark engine. While parameters are supported for data flows, it cannot handle dynamic destination sets. And I want to put a star on that, okay? Because If you use the new Delta Lake format that came out, I don't know, 18 months ago, and again, it's new to me because it's been around for years, that it will allow you to say, hey, just go to this directory and append to it, okay? And so, yeah, it will parameterize it. We have additional 16 transformations that can be used in the ETL process. Wrangling data flows were released in October 2021, which I wrote about. Limited data source types are accepted this time, as well as transformations. So let's talk about what you can do. We always have to use a data set. So once you pull it in, you have a data set that comes in. You can take more than one data set and join it. You can conditionally split it. You can say something exists. You can union. You can look up, right? Once you have that data coming in, you can do things just like in SSIS. I can derive a column. Okay. I can reduce the number of columns by using a select statement. That's what it does. I can come up with a composite of the columns by aggregating. So I can reduce the number and say, hey, I want to aggregate some by this. I can add a surrogate key on it. I can flip the data. If I have rows, I can make them columns. And if I have columns, I can make them rows. And I can do windowing functions, okay? Row modifiers, we can filter. So we can say, hey, reduce the number of rows by where this condition is matched. We can sort, and we can also alter it. Maybe we want to go ahead and change a value. Some things not listed are source, which is the source that comes in, branch at sync, and then new branch. A new branch means, hey, I want to take the results of this and branch out to another way. Okay. Extract, translate, and load pros and cons, right? One of the things I did notice, again, like I said, is that these are not easily parameterized like regular pipelines, okay? There is other options you have though. You have partitioning, how the cluster is going to use Spark, partition it, the batch size and isolation level, okay? Here's the interesting thing though. You might run this the first time and say, hey, you know what? It's taking forever. Why is it going so slow? The reason why is under the hood, right? It's bringing up a Spark cluster. And is with cluster is something called TTL, time to live, right? Databricks cluster takes 3 to 5 minutes to spin up. So if we spin it up, then we run a job every 30 minutes, it goes down. So we start the beginning hour at 0, takes 5 minutes to come up. I run a job's 1 minute. At 6 minutes, it drops down after an activity, say now 5 minutes, 10. Then at the end, we get another job and it says, oops, we have to spin it up again. We have a lot of time. This is spinning up and spinning down. Or if we're running a lot of multiple jobs, like one after another, we keep on incurring this 5 minutes. We don't want that, right? So one of the things you want to look at is time to live. You want to keep that cluster up so it doesn't keep on spinning up and spinning down, okay? Another thing is that parallelism has an overhead, right? So a copy activity of 4 rows in a regular data flow on a small data set is probably going to outperform data flows because data flows are for big data, right? You have to spin up a cluster. One of the features that you can do in here that you can't really do in ELT versus ETL is advanced transformations and lookups, okay? So to round this off, what's best, right? Well, let's look. You want to look at the monthly cost because regardless of who your manager is, they're all going to come to you and going to say, hey, what's the cost, right? And if you decide to put a new product out in the cloud, they're going to say, hey, how much is it going to cost us? What's this monthly runtime, right? If you don't look at the cost of a virtual machine, it depends on virtual machines, right? I mean, low end's $200, right? On average, a regular ADF costs about 262, and this was done a couple of years ago. I don't know if it's fluctuated. You can take a look. If you use data flows, right, a spot cluster, you're going to add an extra $1,500, okay? And you can do this by, spending, budgeting a couple of grand for the first month and test it out. Run 1 month with just ADFs and, pipelines with no data flows, and then next month add data flows and see what the difference is. I'm going to skip over the wrangling data flows and mapping data flows unless you have an extra half an hour. Deepak, I want to be conscious. I'm at Mr. Paul. I want to be conscious
Sure.
of time. Unless you
Yeah, I
want me
don't
to go
think.
into it.
No, I think it will be
Okay.
kind of too much because it's off after office hour and they
Yes,
wouldn't.
exactly. And that's why I figured. So if we had time, one of the things I would show you is how you can use a Wrangling data flow, right? And you could do like an upsert. And I would try to do a same thing with a mapping data flow. Last time I did Wrangling, it was really hard to work with. The mapping, it worked pretty good. Okay. And then last but not least, we talked about Azure Data Factory supporting both EL and ETL designs. Okay. We talked about pipelines, activities, data sets, and link services are at the heart of the engines, right? And what you're going to be using, unless you use mapping data flows, you're going to be using a copy activity, okay? Um, Usually additional computing like an RDBMS stored procedure or Databricks has to be used to actually do the transform. We talked about mapping data flows. It's really an ETL, okay? Starts with source, zero more translations, and ends up with destination, okay? So is there a right way or a wrong way to do ETL? And the answer is it all depends, right? So it depends on your business line managers on the following questions. Does the process actually perform the movement and translation of data? Does the process execute in a given time period at a reasonable level of resources? How much it costs, right? Does it scale? Do we need to have the ability for it to scale? And does the cost meet our operation budget? In summary, you have three different ways to do things, right? I like ELT. Maybe you like ETL. Okay. But I usually use ELT because I know that once I get into the bronze zone, more than likely when I go from bronze to silver to gold, I'm going to probably be doing Databricks anyways. And so therefore, I don't want to pay for Databricks twice. There's a ton of references, showed you the name conventions, pipelines, mapping data flows, wrangling data flows, the self-hosted integration runtime. And at this point, I'm going to wrap it up with any questions. And thank you for being really patient. I know it is a very intense talk, but there's a ton of stuff to cover, and hopefully you learned a few things.
Oh yeah. Thank you so much, Sean. We got a few questions.
Sure.
I think Carlos mentioned earlier. I think this is some more about when you were showing that parameter. You mentioned isn't not available via the monitor pan. Yeah, probably it is. But yeah, just the comments. Let's go
Yep.
to the rest. Next question is Ray. Ray mentioned is derived column works like a calculated column.
You talking about mapping data flow?
I assume so because derived column is there. Yeah.
Yeah,
I think,
it does. And again, it's one of these things you have to draw from left to right and things happen in the order, right? So if we do an aggregate, you would reduce the number of fields, right? So maybe you'd only aggregate on one or two items, right? And then from those one or two items, if you wanted to sum the two, maybe like you aggregated all the quantities and you aggregated all the prices for a certain product. And again, this is a derived solution that might not be right, but at the very end, you drive a column off those two, then it all depends on order. But yes, it will eventually add to the stream that derived column.
also add to that because I work heavily with the data flow. So in the drive column, you will have the regular expression. So you can
Yep.
do so many things with that when it's come to the transformation. Next
Doesn't
question
it
from
have its own set of expressions, if I remember right? Like a whole
yeah
language.
yeah whole regular expression. And the next question from Carlos is there is a big difference in pricing for wrangling and mapping data flows.
Don't know. I think they're pretty similar because they're using the same engine. Here's the problem. Go look at my article on wrangling data flows. In that example, I take a piece of code that I wrote way back when I did a Power BI article. And what it did is it just reads from a web page, Super Bowls, right? And tries to put it into a table, all the content of all the Super Bowls that have ever been played, right? Very simple transformation, right? It works totally fine in the UI. When I go to schedule it through ADF, it fails. And the reason why is that some of the transformations are not available because they have to be translated from the M language, which is a functional language, okay, to now this script that actually gets run on Spark, right? And not everything's supported, okay? So that's one caveat. Right now, I was hoping that Mark took those transformations out. So if you did cut a piece of code in, it's not suggested with it, then it would actually Yeah, he said it's a deal breaker. Yeah, exactly. It's not one to one. You would have to go back and do some manipulation. Look at my article though. There's always a way to do stuff. And so if you want to have it happen, you could. One of the things I did love is SSIS. Let's talk about old stuff, right? I did a plenty of SSIS packages in my day. And guess what? When you cut and paste SSIS, it worked exactly like the Power BI. It worked. Unfortunately, because now you're not doing this a regular exe to run it, but you put it on Spark, it has different rules.
So are you saying, John, here that one hand that's a mQuery, what you can copy actually from the Power BI development, whatever you're
Yep.
doing, you can copy and paste it. And other hand is a Spark cluster running. So are you saying like those two things could be very similar cost? I thought Spark cluster cost more, right?
No, 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 no. No, what I
No?
was saying is that what he was asking is if you cut and paste from Power BI uh, into the new Power BI activity, it doesn't work. And I said, yeah, that's the thing I found. It doesn't work because it has to translate M to a Spark cluster. So I'm saying that data flows, okay, mapping data flows and wrangling data flows, the cost might be similar, but the problem is it doesn't execute the code exactly. You're gonna have to make code changes. What I really liked about SSIS is that in the on premise is that they have a Power Query component. It came out with Visual Studio 2019, and if you took that same program and put it in there, it worked like a champ without any changes. So,
No,
and the
yeah.
reason why is that it's not running on the Spark cluster, it's just running the executable code that they have for an M language versus in ADF, it has to translate it to Databricks Spark, and therefore not everything's supported.
Yeah, my intention to learn the very first part of it is the cost wise, that part I'm
Yes.
interested. So you're thinking even running with the mQuery versus running on a Spark cluster, they're like similar cost, because I was thinking the price wise, a Spark cluster will cost more. So that's not correct assumption.
What are you talking about? Are you talking about data flows
Data flow,
mapping?
yeah, because
I
mapping
think the
data flow
data
that's
flow
right.
mapping and wrangling mappings, if you run the same amount of jobs, that they'll probably be the same because they're running under a Spark cluster, depending on
Oh,
size of the cluster.
okay. So though it's a mQuery, but actually it's run under a Spark cluster or
Yeah,
like,
there's actually,
okay,
if you let's see if there's any other questions. If there's no other
sure.
questions, I will
No,
bring up my blog and show you where you can
no,
actually,
no.
we can actually pick the cluster size, and that's what I'm saying. It all depends on the cluster size you're running. So if you run your data flow on 4 cores and you run your wrangling flow on 4 cores, they do the same thing. And say you run once a day for a month, I think you're going to get the same cost.
Okay, John, we got more question. I can risk
Exactly.
you if I have more question, or so there's more question here. Kang ask, do you need a ETL audit logs if we use metadata driven for our pipeline debug?
Okay, so here's the thing: is that anything in Azure usually has a shelf life for logging, right? So um, usually it's like 60, 30, 60, 90. You can look it up in the documentation. A better way to do it is to, when I do my flows, and I didn't show you because obviously the complexities, you thought this was complex, it would go a lot bigger, right? Every time I do something, right, I probably want to log before it and then between every step and log at the end, right? So now I have metadata in my logging that tells me how long each job step takes, okay? Also on each one of those, I have to put a failure alert, right? So I have another thing coming off calling that. Remember I said you can call a Azure function. That Azure pipeline will call an Azure function and send an email saying, hey, it failed, right? But yes, if you really want to do it, do custom login. You can also ship it to Log Analytics. It allows you to do Custo query if you like versus SQL, whatever. But both are applicable and you can design both.
Okay, John, you raised your hand. Unmute yourself and ask the question, please.
Sure. Excellent presentation, John. Thank you.
Thank you.
My question is how you are able to pass a value from a child pipeline to its parent,
Sure. Let's
other
take a look at
than
it.
store them into a file or database.
Nope. Actually, you can easily do it. I'll show you exactly where it is. Might have went over that, but this right here is execute pipeline, okay? And this ran. And so in the settings, we can see that I am calling, this is pipelines called schedule, but I'm calling the pipeline called copy, which is here, okay? And this is the metadata driven one. And I'm passing it all the parameters, every single parameter right here.
Right.
And so the second call, see, this is the parent, but it's calling the child, and it's given a second different set. Okay, so that's one way to do it. And this one, this metadata happened to be a JSON load, right? We can also go back to the other schedule, and maybe I just didn't show this hard enough, is that in here we can also pass it if we want to do multiples too. So the previous one was better because we could use the lookup activity and say select from a table where a schedule equals 1 and task equals 1, run that, and I could get a payload down that that JSON log of the table and then pass it to the child, just like I did in the JSON one. This one's hard coded and says, hey, I only got 4 parameters, call this start procedure. I meant the pipeline. And then this would be the same thing, try repeating it, start your pipeline and your parameters.
I view this as you passed from parent to child.
Yeah, and this was the parent, which is your schedule.
I want to pass, let's say, the result from the child back to the parent.
Oh, interesting. So, did not get that. There is a return value, and you can capture it that way. I've done it before. I'm going to stop presenting
Really?
and show you my face. I've done it before with Databricks. Databricks will allow you to do a return value and then capture it. And I'm sure that you can do the same thing with a pipeline, but let me get back to you on that one. I haven't done it, but I'm sure it can be done.
Okay, thank you.
Is
Thank you
there a
so
tool to migrate SSIS package? I saw the next question to the cloud. The interesting thing is it's not so much migrating the SSIS package to the cloud, is setting up Azure SQL database and or Azure SQL managed instance, okay, to use some compute to actually run those packages, okay? So when you migrate the packages, you're still going to put it into an SSIS catalog, okay, in Azure SQL database or Azure SQL managed instance, but that has to be hooked up to a self-hosted integration, not self-hosted, but the Azure Auto Resolve for SSIS engine, so it can run that package, okay? Does that make sense? And if you want to get really complex, guess what? If you use custom controls, it has to be a self-hosted integration runtime. Why is that? Because you have to install the components on that runtime, right? Because say if you're using, say, I don't know, remember everybody's been buying everyone up, but it used to be Pragmatic Works. Remember Pragmatic Works had a bunch of controls and they became Century One and Century One became now SolarWinds, everyone's getting gobbled up. But say you still have that product and you want to run that in the cloud, you would install it on your self-hosted integration runtime and then configure that, right? You'd have your catalog somewhere in one of these SQL services, and then you'd hook that to your Azure runtime, and they would call the VM, and everything would suddenly work.
Yeah, awesome. I think there is no more question here.
I think it's beer time.
It is great session, very good engagement, a lot of question, and I hope you folks actually learned something from her. I learned a lot, and I'll have more question to John. I'll ping him.
Please
You can
invite
do
me
too.
back. I know a lot of stuff. I can come back and talk about Spark or Snowflake. But Deepanke and Mr. Paul, thank you again for having me, and have a wonderful night. I really appreciate you having me.
Same here. It's our pleasure to have you on in our event.
Thank you.
Hopefully, I don't know if you have time even to come in person, visit us. That'll be awesome. We'll love that.
Remind me when it's coming up, and I'll see if I can make some plans.
Great. And thank you, everyone. Thank you so much for joining today, and have a wonderful evening.
Take care. Bye-bye.
And please also share your PPT or the resources with us, John, so I
Sure.
can share with all the audience.
I'm going to put it right in the chat window. Up front, I did that, but it's my GitHub, and I'm going to put the GitHub. And then what I'm going to do is I'm going to pop it right in here. So Azure Design Patterns. So I am cutting it and then pasting it right there.
Thank you. Anyway, I'm gonna send the email with video and everything together, so you all gonna get everything. So, right.
Thank you, everyone. Have a nice night again. Bye.
Thank you. Thank you. Bye. Bye, everyone.
Thank you.